The last thing we're going to do in this unit is to kind of catch a couple of small trig problems, but if you don't see them, they might get kind of confusing without an explanation. While the Pythagorean triples are not part of your trig problems, they are oftentimes used in trig problems, and the ones that you'll probably see most often are 3, 4, 5, or its family. So 3, 4, 5, and then if you doubled everything and got 6, 8, 10, or tripled everything, 9, 12, 15. So it's the whole family. 6, 8, 10 I actually already mentioned. In fact, I said I think a few of these. Let's see. The other ones you might see pretty often, 5, 12, 13, 8, 15, 17. Some of the other ones maybe, maybe not. We'll see if we find some more that are not in here, but these are the common ones. All right. So in problems 1 through 4, I am giving you one trig ratio and asking you to find a different one. Now, we did stuff like this when we were dealing with the law of cosines problems, and I gave you a triangle, and I said to find the tangent of something, or the sine of theta. So this is kind of in that same vein. So problem number 1, first thing I want to do is draw a triangle. So we've got a triangle ABC, and we know that theta here has a sine of 7 over 41. So sine is opposite over hypotenuse. And we basically want to or need to find this blank side so that we can figure out tangent. Now, if we take a look at our information, 7 and 41 don't show up in the common Pythagorean triples. It is actually a common Pythagorean triple, with the other leg being 40. If you want to double check or you just forget your triples, you can always set this up. X squared plus 7 squared is equal to 41 squared. So if I take 41 squared minus 7 squared, I believe I get 1600. Okay, maybe I made a mistake then. Okay, it is not the triple I thought it was. So I may have made this problem a lot more difficult than I thought it was. So 41 squared minus 7 squared is 1632. Let's see if I can take the square root of that if it turns out. No, it does not turn out pretty. So x is going to equal the square root of 1632. I'm not going to worry about having you guys simplify when they do this weird stuff. If your calculator does simplify, great. If not, no big deal. Yep, okay. So in terms of this blank side, I now know is the square root of 1632. So if you need to find the tangent of theta, so tangent of theta would be opposite over the adjacent side. Now, we really should rationalize this, so we're going to multiply top and bottom by 1632, and that is not, 1632, that is not divisible by 7, so that's just going to stay that denominator. So I don't think I intended to make this problem quite that weird, so we'll just deal with it and move on to the next one. But the process is basically the same idea. All right, so given triangle ABC, so we're going to start the same way. This time we have cosine of alpha, and alpha could be either of the two acute angles. It won't matter which one's which. So cosine of alpha is 2 over 5. Find the value of cotangent of alpha. So I'm still going to need this blank side. So to find that blank side, I'm going to take a quick look. Yeah, 2 is not one of my Pythagorean triples anywhere, so this is not going to be helpful. But what I can do is, let's say, a squared plus 2 squared is equal to 5 squared. So a squared is equal to 5 squared minus 2 squared, which is 21. So that turns into the square root of 21 there. All right, and there's nothing we can do to simplify that, so that's okay. So let's see. cotangent of alpha would be the reciprocal of tangent. So tangent is opposite over adjacent, so cotangent would be adjacent over opposite. So cotangent of alpha would be 2 over root 21. If I rationalize this, it's the same thing I did in the last problem. I'll just show the step this time. So cotangent of alpha would be 2 root 21 over 21. And this is where you want to be careful of finding the exact values versus if I'm asking for a decimal. For these problems, I probably should have put exact values, but that's what I'm looking for with them, so just be careful. Okay, so again, triangle ABC, I've got theta is equal to, tangent of theta is equal to 3 over 5. So opposite over adjacent, and we need secant. Secant is the reciprocal to cosine, so I am going to need the hypotenuse. All right, so to find the hypotenuse, we're going to do 3 squared plus 5 squared is equal to h squared. So let's see what we get here. That's going to be h squared is equal to 34. This is going to be square root of 34 here. All right, so that's not going to reduce in any way, shape, or form. So the secant of theta, well, cosine of theta is adjacent over hypotenuse, and cosine and secant are reciprocals. So I'm going to do hypotenuse over adjacent. So root 34 over 5. Because the root is already in the numerator, I do not need to rationalize at all. So that part's done. Last one in this set. So let's see. Given triangle ABC, in this case we have beta, so we have cosecant of beta. Cosecant of beta would be the reciprocal to sine. So that would be hypotenuse over opposite. Find the value of cosine of beta. So I do need this adjacent side. So Pythagorean theorem, 7 squared is equal to 2 squared plus a squared. So 7 squared minus 2. I hit the wrong things on the calculator. There we go. So this would be 45. If I take the square root of both sides, I'm going to get 45 has a built-in 9 in there. So that would be 3 root 5. All right, so 3 root 5. So then the cosine of beta, so cosine of beta would be the adjacent side over the hypotenuse. The numerator already has the root in it. I can't simplify 3 over 7, so that fraction is the exact value for cosine of beta. All right, so those are a little bit weird, but again, we've seen a couple of them like this earlier, so I just wanted to clarify a few things, and if possible, use the Pythagorean triples. All right, now problem number 5 and 6, you were asked to find the perimeter given certain information. Now, in order to find the perimeter, we need to know the exterior sides, and in the case of problem number 5, I only know one of them. But I'm also given this information that the sine of theta is 4 over 5. Well, sine is opposite over hypotenuse, so this is 4 over 5. But you may recognize this side was already marked with an 8, so that's a little bit weird. So I'm actually going to ignore the 8 for right now and figure out what the 3 sides of this triangle are when they've been reduced. So I know this is 4, I know this is 5. This is actually a Pythagorean triple. It's called a 3, 4, 5. And so I've got the ratio set up here, 3, 4, 5. Now what I need to figure out is how do I get from 4 to 8? And then what happens is basically these original ratios, this original 3, 4, 5, everything was doubled. So 4 doubled up to 8. 5 is going to double up to 10, 3 doubles up to 6. Now, when I'm finding the perimeter, I'm going to add up these exterior sides and get my perimeter that way. So perimeter, I'm just going to use P is equal to 8 plus 6 plus 10 So, and I don't know units on this one either. If you did, of course, we would want to use them. So perimeter is going to equal 24 here. Okay. So be careful that you don't mix and match. This 8 is not in the same ratio set as this 4 and this 5. So basically what happened is we had the 8 over 10 and it got reduced to 4 over 5. So we're kind of trying to figure out how to unreduce it to get back up to what the triangle was equal to. All right, one more problem here. Given the cotangent of alpha, so cotangent of alpha means I would do adjacent over opposite. So 24 over 7. Now I'm going to do a quick pinch in and go up to my triples here. Let's see. 24 and 7. Oh, there it is. So 24 and 7 with a hypotenuse of 25. See, those Pythagorean triples come in handy. So 7, 24, 25 is the small simplified values, but I want to figure out how to get to the actual perimeter that I'm using here. So in this case, how do I get from 7 to 21? Triple it. So I want to triple all of these interior values to get the actual perimeter values I need to use, or actual side values. So this is going to be 75 here, and 24 tripled up is 72. So my perimeter is going to be 21 plus 75 plus 72. Order doesn't matter when you add them up. So 21 plus 74 plus, no, 75 plus 72. Let's get those all in the right order. Perimeter is 168. We don't know the units here. If you did, please add them on. All right, so these are just a couple of different kinds of problems that you might see using the different trig values.